Buckle up, amigos. We got a long ride today on this vertex form of a parabola. So standard form is on the left, vertex form is what we're going to be looking at today, and that's on the right. So vertex form has an A, H, and K. You might remember this A, H, and K from absolute value functions. That A is going to be in charge of a stretch, a compress, or a reflection. The stretch will happen if A is greater than 1. The compress will happen if A is between 0 and 1, and the reflect will happen if A is negative. The H is going to affect our X value. So if it's a negative H value, it's going to shift us right. And if it's a positive H value, it's going to shift us left. K is a vertical shift. So if it's a positive, it's going to shift us up, and negative is going to shift us down. Remember that these shifts that we're talking about happen from the parent function, which we'll look at later on in this lesson. We're going to look at how to find these key features in standard form and in vertex form, but we'll only look at examples from vertex form today. There'll be a video coming out soon about the standard form. So to find your vertex in standard form, you're using a formula, negative b over 2a. And then whatever value you get there, you're going to plug in for x to find the y value of your vertex. From vertex form, it's a lot easier. You just look at the opposite of the h value and exactly the same as your k value to create your vertex. To find our y-intercept when we're looking at standard form, we're looking at 0, c. So we're looking at that c value like when we looked at a, b, and c for quadratic formula. For the y-intercept in vertex form, we're plugging in 0 for x to solve for y, just like we would find a y-intercept in any other type of function. For x-intercepts, in standard form, that's when you're going to use that quadratic formula, or you're going to factor and set each factor equal to 0 to find your x-intercepts. In vertex form, you have to plug in 0 for y and solve that equation to find those x values. So this seems like an overload of information, but we will see examples of these very soon. Your axis of symmetry, when you're looking at standard form, you're using that same x equals negative b over 2a as you do to find the vertex. So really you can just remember that your axis of symmetry is x equals the x value of the vertex. You can use this trick for both forms, standard form and vertex form. Now we want to look at how does the parabola open? It's either going to open up or it opens down. That's where the a value comes in. If you have a positive a value, you have no reflection. That parabola is open up. But if you have a negative a value, that's a reflection over x. So you're going to have a parabola that opens down. Now, parabolas go to the left and to the right forever and ever and ever. So the domain for parabolas are always negative infinity to positive infinity because you're reading your graph from left to right, and those arrows are pointing left forever and right forever. Remember that our range comes from reading our graph from the bottom to the top. So we'll have to look at a graph of a parabola to try to figure out what this range is going to look like. There are some tricks to remember it, but remember you're just reading your graph. To understand what these look like, we're going to first look at the parent function, y equals x squared. Y equals x squared is in standard form and it's in vertex form. So if I look at the opposite of h, there is no h, exactly k, there is no k, so that's 0, 0. Our y-intercept is also at 0, 0. If I plug in 0 for x, I'm going to get y equals 0. And vice versa. If I plug in 0 for y here, I'm also going to get 0, 0. So a lot of our information from the parent function is a lot of zeros. It doesn't really help us understand what all these pieces mean, but it's good to know what the parent function looks like. The axis of symmetry is a line that shows that one side of the graph is symmetrical to the other side of the graph. And the axis of symmetry is x equals the x value of the vertex, so that's going to be x equals 0. The parent function opens up because the a value is a positive 1. It also has a domain from negative infinity to positive infinity. And now we're going to see what it looks like on a graph. A graphing calculator is definitely going to help you figure out your tables and what your graph looks like a lot easier than it would be to plug in a bunch of different x values and try to figure out your life that way. So I want to put my vertex right in the middle of my t-table, and I'm just going to copy that from my calculator. If I don't have a graphing calculator, I'm going to have to make these values by hand. So the trick is put your vertex right smack dab in the middle of that table and find some points on either side of your vertex. That means that if you don't have a graphing calculator, you have to choose the x values and plug those into the equation to find the y values. It takes a lot of time. This is what those points look like on a graph. So we can see that nice, pretty U shape of that parabola. We can see that it opens up. We can see our x and y intercepts. The axis of symmetry here is our y-axis. So we can see that that graph is symmetrical on either side of that y-axis. We can also look at our range now. So from bottom to top, that first y value we get to is 0. I put a bracket because it's included. It's a point that I can see and I can touch on that graph. As we look up towards the top of the graph, that points towards positive infinity. We don't use a bracket when we put infinity because you cannot touch infinity. Buzz Lightyear said to infinity and beyond. Here we have an example in vertex form. It's in that form a times x minus h squared plus k. We can take the opposite of h and exactly k to find the vertex. So the opposite of +1 is -1, exactly the same as 2, which is just 2. To find the y-intercept, you're going to plug in 0 for x and do the math involved there. So it's going to be different every time depending on what equation you have. Here I'm simplifying using PEMDAS, parentheses, then exponents, then multiplying by that negative, and then adding 2, which gives me the point 0, 1 for my y-intercept. To find my x-intercept here, since we're looking at vertex form, I'm going to plug in 0 for y, and then I'm going to solve for x. So I'll subtract 2 from both sides. 0 minus 2 is just -2. I'll bring everything else down. I need to get rid of that negative sign in front of those parentheses before I can get rid of my exponent. So I'm going to divide both sides by -1. That's just going to change the sign of that -2 to a +2. And then I can take the square root from both sides. In front of that square root of 2, I'm going to need a plus or a minus sign. Think back to that quadratic formula. And on the other side, that square root and that to the second power cancel out so that all that's left is x plus 1. So I have one final step here. I want to subtract 1 from both sides, but I want this to look like when I solved in quadratic formula. So I'm going to put that -1 first and then the plus or minus square root of 2. That -1 plus or minus the square root of 2 gives me 2 decimals. And I do want to find those decimals so that I can put this on a graph. So I'm going to type -1 plus the square root of 2 into my calculator. Every calculator is different, so yours might not look like mine. You're going to have to learn your own calculator and see how to type this in. Look it up on Google, YouTube, how to use your specific type of calculator. So now I'm going to plug in -1 minus the square root of 2, and that gives me 2 irrational decimals. We're going to write these 2 decimals as points. Remember that we plugged in a 0 for y, so my x value will be that decimal that I found, and the y value will be the 0. You're going to be plotting these points on a graph, so does it really matter if you're going to write -2.4 or -2.41? No. So here's my 2 points, -2.40 and 0.40. I'll go ahead and finish up the rest of the key features. We know that this graph opens down because my a value is a -1. We know that the axis of symmetry is x equals the x value of my vertex, so x equals -1 here. And then we know that domain for quadratics is going to be -infinity to +infinity, and then we'll see what this looks like on a graph to figure out our range. I am doing this in my graphing calculator, so I have typed in the function into y equals in my graphing calculator. When you type these into the graphing calculator, you want to make sure you type it exactly how you see it. So I'm going to go ahead and look at my table, and I'm going to make sure that my points are correct. So I can see that my vertex is on there, -1, +2. I can see my y-intercept, 0, 1. So I know that I found those points correctly. And I'm going to copy that table onto my paper, putting that vertex in the middle and having those symmetrical y values surrounding that vertex. Unfortunately, if you do not have a graphing calculator, you're going to have to choose those x values that are surrounding your vertex. So you're going to have to choose -2, -3, 0, and 1, and plug those into the original function to find the y values. Get a graphing calculator. The Casios are like $40 on Amazon. Just get one. You're going to need it. Also, disclaimer, if you hear some heavy breathing, that's my dog. He's sitting next to me and snoring right now. So now I'm going to go ahead and plot these points onto my graph, and I want to take a look at what the graph looks like. So I did press the button that says graph on my calculator. When I plot these points onto my graph, these points should look like they're placed exactly where those points are placed on my graphing calculator. This graphing calculator is going to help you match those points that you found algebraically, like the y-intercept, the vertex, and all the other points that you're finding in your t-table. If your graph does not look symmetrical around that vertex, then you did the math wrong. So check it. Notice that my x-intercepts match up where they're supposed to go. -2.4 is about right here. And positive 0.4 is about right here. So those points that I found algebraically do match up. Now that we have this graphed, we can look at our range. Remember that you read your range from bottom to top. So as you start from the bottom, the first values that you should see are those arrows that are pointing down to -infinity. Remember, we can't quite touch -infinity, so we're going to use those parentheses there. As we come up to the top, that last y value that we see is the y value of our vertex, which is +2. We're going to use a bracket there because we can see +2, we can touch it, we can plot a point at +2 for y. Now I'm going to mark up this graph just so we can identify what all of these different pieces mean. So that vertex is the point where the two sides of the parabola meet. The y-intercept is that point that crosses through the y-axis. Those x-intercepts are points where the graph passes through the x-axis. Remember that not all parabolas are going to have these x-intercepts because they might not pass through the x-axis. And we learned that when we talked about quadratic formula. This axis of symmetry is an invisible line, and it separates those two sides of that parabola, the two sides of that U shape. And I often refer to that axis of symmetry as just AOS. All right, here we go with example 2. I know these are hefty, but it's good practice. Opposite of h is going to give me a +4. Exactly k is going to give me a -5. My y-intercept, remember, comes from plugging in 0 for x. So when I plug in 0 for x here, I'm just solving this using PEMDAS. So 0 minus 4 is -4. -4 squared is 16. And 16 minus 5 is 11. So my y-intercept is going to be at 0, 11. For my x-intercepts, I'm plugging in 0 for y. So I'm going to end up having to solve an equation. Here, I'm trying to figure out where I'm going to write this. I'm squishing it in. So here, I'm solving this equation using backwards PEMDAS. So I'm going to add 5. That's going to give me 5 on the left side because 0 plus 5 is just 5. And then x minus 4 quantity squared on the right side. I can take the square root of both of those because I don't have a number in front of those parentheses. Remember, I want to put a plus or minus in front of that square root of 5 because I want this to look like quadratic formula answers. And then when I add 4 over, I want to put that +4 in the front and then the plus or minus square root of 5 at the end. Then I can put both of these values into my calculator to find their decimals. So to get those decimals for those x-intercepts, remember I'm plugging in 4 plus the square root of 5 and 4 minus the square root of 5 into that calculator, which is giving me that 1.80 and that 6.20. From here, I can see that the graph opens up because of that +1 in front of that set of parentheses. The axis of symmetry is x equals the x value of the vertex, so x equals 4. The domain is going to be -infinity to +infinity because it's a quadratic, and the range we will see once we graph this. In my calculator, I'm typing exactly what I see into my y equals button. So I put x minus 4 in parentheses to the second power, -5, and I hit enter. Mine changes it so that it looks all fancy, but yours might not. Just let it happen. I hit graph so I can see what this looks like. And I'm going to check some of my points now on the table. So I'll hit table on my graph. I want to go find where that vertex is at +4, -5. And then I'm going to copy those table values onto a t-table onto my paper. Again, if you do not have a graphing calculator, you're going to put your vertex right in the center of that X and Y table. So you're going to put 4, -5 right in the middle. And then you're going to pick X values to the left and to the right. So you're going to have to choose 2 and 3 and 5 and 6 and plug each one of those in for X. Use PEMDAS and find the answers for Y. It's a lot of work, but if you had a graphing calculator, life would be easier. So here I'm going to put those table values onto my graph. They should match what I see on my calculator. So again, I'm using that calculator to help me make sure that I've graphed the correct points or that I've found the correct values using algebra. I can see that the X values that I found for my x-intercepts match up. So 1.80 matches right up with the graph that I've put on my paper and the graph that I see in my calculator. So does 6.2, 0. My y-intercept is up a little bit too high, so I can't plot that on this graph right now, but I can see that that left side of the parabola will end up passing through 0, 11 up at the top. For this range, that first y value that we get to is that y value of my vertex, because this time my graph is pointing up. So my first y value is -5 with a bracket, and then those y values go up to +infinity with parentheses. I do want you to pause here and do as much as you can. I will reveal a little bit at a time as we go through and check this U-try. So pause here, try as much as you can, and come back when you're done. All right, so hopefully we've got this vertex down. The opposite of H, +3, and exactly K, +4. When you plug in 0 for X, you should get 13 for Y. Follow PEMDAS. Now, if you get stuck on these x-intercepts, I'll show you the work for that. So I'm subtracting 4 from both sides. I get -4. And then when I take the square root of this, what is the square root of a negative? We talked about this before. It's imaginary. This is an imaginary solution. This means that we have no x-intercepts. So for x-intercepts here, I'm just going to write none because we have none. The graph opens up because A is equal to +1. The axis of symmetry is X equals the X value of the vertex. And the domain is -infinity to +infinity. When I put this into my calculator to graph it or to find the t-table values, remember I'm typing this exactly how I see it on my paper. Look at that. I don't have x-intercepts. This graph is hovering up above that x-axis, which is exactly what I wanted to see. And again, I'm either choosing those values based on my vertex or I'm just copying from the table of values on my calculator. I made my graph big enough so that we can see that y-intercept at 0, 13. And then from here, I'm just going to plot the rest of my t-table values onto my graph. I do want to look at the axis of symmetry just a little bit more here. So notice that I have that point at 0, 13. I can actually mimic that y value at 6, 13. Because if I'm looking at that axis of symmetry right here in the middle at x equals +3, my 0, 13 is 1, 2, 3 spaces away from that axis of symmetry. So it should have another point on the other side 3 spaces away from the axis of symmetry because those points should match each other on both sides of that parabola. Last piece that we're talking about here is the range. Remember, we read that range from bottom to top. That first y value that we get to from the bottom is that 4 from the vertex. And then the last y value that we get to are those arrows pointing up towards +infinity. I know that was a lot. Thanks for coming. We'll see you next time.